The bane of my existence. Supporting both async and sync code in Rust. Sit beside me and hear this crazy old man's tale of when I asked Rust for too much. Okay, I like this. Introduction. Imagine you want to create a new library in Rust. Loser. I actually did that right now. All it does is wrap up a public API that you need for something else, like the Spotify API, or maybe a database like OrangoDB. I swear every time I read a database, like every time I see a database on any blog post, it's a database I've literally never heard of. There's only one thing I think that outproduces JavaScript frameworks, and that's databases. There are more databases than there are JavaScript. Now that, my friends, that is the ultimate Jimmy Rustler. Okay? Because, like, what are you going to do? Argue the contrary? What? Dude, this is the ultimate Jimmy Rustler right here, okay? I love it. I'm so excited about it. We'll see where that one goes. We'll see where that one goes at the end of this, okay? Go back to this. Oh, it's so good. It's so good. Tweeting while streaming is where all my tweets come from. All right. It's not rocket science. You aren't inventing something new or dealing with complex algorithms, so you expect it to be relatively straightforward. You decide to implement the library with async. Loser. By the way, my last library that I've been trying to do at Netflix, I tried to use just channels and no async, like actually spawn threads and just do it like all myself. Dude, I skill issued myself so hard, gave up and went back to Tokyo and async. I'm such a loser. Literally just have a global semaphore that I use as a lazy static to create, so I can't make too many concurrent requests across my program. Dude, I'm such a loser. I am such a loser. All right, anyways. Most of the work in your library has to do with performing HTTP requests, which are mostly I/O. So it makes sense that, and because you want the cool kids, because that's what the cool kids use in Rust nowadays. You start coding and have a V01 release ready in a few days. Neat, you say, as Cargo finishes successfully and uploads your work to Crates IO. A couple days pass and you get a new notification on GitHub. Someone opened an issue. How can I use this library synchronously? My project doesn't use async because it's overly complex for what I need. I wanted to try your new library, but I'm not sure how to do it easily. I would rather not fill my code with block on endpoint. I've seen crates like request export blocking module with the exact same functionality. Could you perhaps do that as well? I did. I literally also used request blocking module to try to do my own threading. Again, skill issued. I got skill issued so hard. Holy cow. Low level wise, that sounds like a very complicated task. Having a common interface for both async code, which requires a runtime like Tokyo, awaiting futures, pinning, etc. Still don't know what pinning is. I mean, I know what pinning is, but I don't understand it. And regular sync code, I mean, they asked nicely, so maybe we can try. After all, the only difference in code would be the occurrences of the async and await keywords, because you aren't doing anything fancy. I feel genuinely bad for this because, here's the problem is you can't just block with Tokyo, right? You can't just block on it because the moment you block on something, all of a sudden your Tokyo, it gets all effed up. So you can't just make sync code and then throw it like in a Tokyo spawn. You can't just do that. Coloring is the worst thing in the universe. Well, this is more or less what happened with the crate Spotify. I thought that was Rust Potify. It's actually Rust Potify. Okay? It's a pot distribution network. You wouldn't understand. You just wouldn't get it. Okay? I created the Rust Pocket-based client lib. Not even joking. This literally what happened. This literally happened to you? Dude, it seems really hard. Honestly, like I said, I tried to write my own sync stuff just recently. Rust is genuinely hard. I have fearful concurrency. I have fearless await for fearful concurrency. Well, this is more or less what happened with the crate Spotify, which I used to maintain along with its creator, Ramsey. For those who don't know, it's a wrapper for Spotify Web API. To clarify, I did get this working in the end, although not as cleanly as I was hoping. I'll try to explain the situation in this article. Okay. To give more context, here's what our Spotify clients look like, roughly. impulse Spotify, async some endpoint, self param string, Spotify results string, mute params, hash map new, insert param, get some endpoint params, await. Okay. Essentially, we would make some endpoint available for both asynchronous and blocking users. The important question here is, how do you do this once you have a dozen endpoints? How can you make it easy to switch between async and sync for users? I assume copy and pasting, yeah. This is what was first implemented. It was quite simple and it worked. You just needed to copy regular client code into a new blocking module for RS Spotify. Request our HTTP client and request blocking share the same interface, so we can manually remove keywords like async and .await and import request blocking instead of request in the new module. Nice. How does this feel right now? How does this feel reading what's happening? Like, just reading this, I'm emotionally getting just hurt. You can definitely do blocking. You'd put it in spawn blocking. Yeah, but spawn blocking is like a special one-thread item. You don't have the same amount of threads, if I'm not mistaken. Again, I haven't explored it too much, but I'm pretty sure spawn blocking is not the simple fix here. I hate it, but this is exactly how I would do it. This is exactly how I would do it too. I guess I'm creating two of them. Anyways, then the RS Spotify user can just do RS Spotify blocking client instead of RS Spotify client and Viola. Their code is now blocking. This will bloat the binary size for async users, async only users. So we just feature gate it under the name blocking and done. Boom, bang, bomb. Love it. Love it. Okay, hold on. Yo, calm down. Okay, calm down. Yes, this is obviously better than just using bidirectional channel and a wait group and go. Okay, come on. Hey, we're not talking about Go right now. The problem was much more clear later on, though. Half the crate's code was duplicated. Adding a new endpoint or modifying it meant writing or removing everything twice. There is no way to make sure both implementations are equivalent unless you test absolutely everything, which isn't a bad idea either, but maybe you copy-pasted the test wrong. How about that? Atheist. The poor reviewer would have to read through the same code twice to make sure both sides look all right. Damn. Which sounds incredibly prone to human errors. Yeah, this does not sound fun. I never even thought about that. Warning, copy pastas. Yeah, I know. I didn't even think about that every time you write a test, you have to also copy pasta your test. Where's your Ferris now? Let's see. In our experience, it really slowed down the development of RS Spotify, especially for our new contributors who weren't used to the whole ordeal. As a new, excited maintainer of RS Spotify, I began to investigate other possible solutions. All right. Calling block on. The second approach consisted on implementing everything on the async side. Then you just make wrappers for the blocking interface, which call block on internally. Block on will run the future until completion, basically making it synchronous. You still need to copy the method definitions, but the implementation is only written once. I assume you still need an async runtime, though. So if you tried to write sync code, you'd still have like an async runtime running in the end, right? Is that what would happen? Where's runtime being defined, by the way? Sounds like it. Yeah, it kind of sounds like you'd have to have like a whole other thing involved too. Note that in order to call block on, you first have to create some kind of runtime in the endpoint method. For example, Tokyo. Tokyo! Yeah. This does not sound fun, by the way. This raises the question, should we initialize the runtime in each call to the endpoint, or is there a way to share it? Oh, lazy static arc mutex. Lazy static arc mutex. Or arc or whatever it is. I don't even know what it does. It mutate? I have no idea. Anyways, okay. We can keep it as a global. Ew. Our globals, ew. Why do people have constant upsetness about globals ever? You know, every now and then a global's fine. I said it. I am not 100% opposed to singletons. Every now and then I have a singleton I need, you know? Every now and then I just need a singleton. Yo, dog, I just need one of them. I rarely use them because often I shoot myself in the foot, but I will use it. You know what I mean? Or perhaps better, we can save the runtime in the Spotify struct, but that seems crazy, but it seems to take a mutable reference to the runtime. Yep, I was about to say that. Then you have to wrap it in arc mutex. Let's go. You don't. Imagine. Okay, for those that aren't seeing what's funny about this, is that imagine you did this. Right? What makes this so funny is the following. Here, hold on. What makes it so funny is, let's say you spawned 2 threads, right? You have 2 threads that are running, and each one of them wants to make a request, right? But your library has a hidden internal runtime that has an arc mutex. So when this guy calls A and this guy calls B, A goes here and sits on the mutex, and this guy has to wait. He's just sitting in line waiting for this one to be done. And so the duration of A, let's say this long, it has to be weighted by B, and then B can now make the request. Like, how funny. I mean, this is, I would have tried this though, but it's hilarious, right? Like, you know, like, I love Rust. Again, I love Rust. It's one of my favorite languages. But again, this is like 14 seconds of overhead and go. You know what I mean? Like, this is like 0 seconds and go. Like, you're just done. You're like, you just do it. You literally just do it, and that's it. That's it. You just do it. New Go convert? No, I've been on and off Go convert for about 5 years now, and I keep on trying to make Go not happen. Go's like the opposite of fetch. I keep trying to make fetch happen, and then I go back to Go and I use it the most begrudgingly way I've ever used it. I just use it and I complain the whole time, like, this is so stupid. I absolutely hate it. This is just the worst language ever. Shit, I'm done. Okay, well, I guess I don't need to program anymore because I completed my project super quick and everyone's very happy with it. I'm fine, whatever. This is so stupid. I better make a quick feature to this. It's so stupid. And then it ends up being super successful. You keep saying fetch. Are you serious? Are you not aware of the fantastic film Mean Girls in 2004? Really? It's a national treasure. Okay? I also, looking this up makes me feel old and sad. I just want you to know right now that I feel old and sad that I just looked up this film and it's 20 years old and now I feel shitty, okay? Stop trying to make fetch happen. That's so fetch. Stop trying to make it happen, okay? Fetch ain't happening. Anyways, I keep trying to make Go not happen, and it keeps happening. It keeps happening. I know. Sorry for, first off, I just ruined like a huge portion of people's day today. I'm sorry. Feels so stupid right now. The proper way to do this is with Tokyo's handle, which looks something like this. Lazy static. Dude, okay. I feel like, have I pre-read this? I'm literally thinking, I feel like I thought, me and this guy have had the same line of thought through everything, and that's because I suck at Rust again. Dude, I've been doing Rust. I've done hundreds, if not thousands of hours of Rust, and I still am not good at Rust. I have pre-lived this problem. I know. Endpoint. Here we go. I've never actually tried to do what he's doing, and I still am baffled by it. While the handle does make our blocking client faster, there's even more performant way to do it. This is what request does, or itself does. In the case you're interested, in short, it spawns a thread that calls block on, waits on a channel with jobs. Oh, it spawns like a hardware thread? Is that what it does? Oh, that just took me all the way out here. Let's just see what it does. What is thread? Sorry, I don't have my client. I don't have my LSP, so I don't know how to hop around. Standard. Oh, it is a standard thread. Oh. Okay, so that's a hardware thread, right? I'm not stupid, right? It's just straight up spawning a good old fashioned. Just spawning a good old fashioned thread. Okay. This makes sense. You can't use the runtime for this because it Fs everything up. The whole thing gets F'd up. You have to import a runtime. I lolled out loud, yeah. Let's see. Okay, hold on. Let's find out. Okay. Where were we? Where were we? Here, I know where we were. 2, 3. Yeah, there we go. Right here. Unfortunately, this solution still has quite a bit of overhead. You pull in a large dependency like futures or Tokyo, and include them in your binary. All of that in order to actually end up writing blocking code. So not only is it a cost at runtime, but it's also compile time. It feels wrong to me. Agreed. This is a heavy agree. And you still have a good amount of duplicated code, even if it's just definitions that can be summed up. Request is a huge project and could probably afford this for their blocking module. But for a less popular crate like Spotify, this is harder to pull off. I would assume that no module can really pull this off. Duplicating code is extremely difficult and costs a whole bunch. Duplicating the crate. Another possible way to fix this, as the feature docs suggest, creating separate crates. We'd have Spotify sync and Spotify async. A user would just pick whichever crate they want as a dependency, even both if they need to. The problem, again, is how do we exactly generate both versions of the crate? I was unable to do this with copy-pasting the entire crate, even with cargo tricks like 2 cargo toml files, 1 for each crate, which was quite inconvenient. Could you do an RS build and generate the sync code at build time? Is that crazy? Probably too crazy. With this idea, we can't even use procedural macros because you can't just create a new create within a macro. Okay, fair. We would define a file format to write templates of Rust code in order to replace parts of the code like async await. But that sounds completely out of scope and it sounds crazy, honestly. As I was saying that out loud, I'm like, dude, imagine building Jinja templates for Rust. You have some sort of like template language to generate your Rust code. Oh. Counting Tokyo as a dependency is wrong since standard doesn't literally provide a runtime. Yeah, but counting Tokyo as a dependency is wrong. Of course. That's what I'm saying. Counting Tokyo as a dependency is wrong. Because a blocking crate, if you only have blocking, you shouldn't have Tokyo. Right? What ended up working? The maybe async crate. Maybe a third attempt is based on a crate called maybe async. I remember foolishly thinking it was perfect solution back when I discovered it. Anyways, the idea is that this crate can automatically remove async and await occurrences in your code with procedural macros, essentially automating the copy pasta process. Oh, that's a good attempt. That's a really cool attempt. I don't see how that would work, but okay, I like it because you got like request has this whole blocking thing. You can configure whether you want asynchronous or blocking code by toggling the maybe async is sync feature when compiling the crate. The macro works for functions, traits, and impl blocks. If one conversion isn't as easy as removing async and await, you can specify custom implementations with the async impl and sync impl procedure macros. It does this wonderfully, and we've already been using it in our Spotify for a while now. Oh, clever. That's pretty, I mean, it's pretty clever. Maybe always makes me nervous inherently. It should. In fact, it worked so well that I made our Spotify HTTP client agnostic, which is even more flexible than being async sync agnostic. This allows us to support multiple HTTP clients like request and urec. You wrecked, boy, independently of whether the client is asynchronous or synchronous. Being HTTP client agnostic is not that hard to implement if you have maybe async around. You just need to define a trait for HTTP client and then implement it. Okay, this is actually pretty impressive. I didn't know about maybe async. This is cool. A snippet of code is worth 1,000 words. All right. Trait, HTTP client, get string, sync implementation, urec, async implementation, request, Spotify, endpoint. Let's go. Oh, cool. I don't understand this syntax, but this is cool. Is this the equivalent of where HTTP is this thing? Is that like the equivalent of this? Is that what this is supposed to be? Trait bound? Yeah, okay. This is a trait boundary inside of inside the generic statement. Okay. I've always just used where T colon is all these things. I never really specify them right here. Okay. It's the same thing? Cool. Is that something like inheritance? No. It's specifying what the thing can be, right? It's like saying this item must adhere to this interface or more. I'm using the term interface because I assume that you're just not familiar with Rust, so that makes more sense. And an HTTP client is defined right here. HTTP client must have this async function right here. The sync version looks like this. The async version looks like this. A little bit confused how this exactly works because this thing defines it as async. Oh, but it's a maybe async, so it allows this async to be dropped in favor of this if you have the okay. Then we would extend it so that whichever client they want to use can enable the feature flag with their cargo toml. For example, if client urec is enabled, since urec is synchronous, it would enable maybe async is sync. In turn, this would remove the async await and then impl async blocks, and the RS Spotify client would use urec's implementation internally. This is actually pretty cool. I didn't realize maybe async. I mean, it's pretty cool. I see the problems coming up, but it's still pretty cool. The solution, let's see, has none of the downsides I listed previous attempts. No code duplication, no overhead, neither runtime nor compile time. If the user wants blocking client, they use urec. It doesn't pull in Tokyo and friends. Quite easy to understand for the user. Just configure the flag in cargo toml. However, stop reading for a couple minutes and try to figure out why you shouldn't do this. In fact, I'll give you 9 months, which is how long it took me to do so. I honestly don't know why. I can't think of why, so I don't know. Because I don't have 9 months to think about it. The problem, Ferris? Rust is the problem. Rust itself is the problem. All right, let's see it. Well, the thing is that features in Rust must be additive. Enabling a feature should not disable functionality. It should usually be safe to enable any combination of features. Oh, maybe async is an either or. You can't have both. Cargo may merge features of a crate when it's duplicated in the dependency tree in order to avoid compiling the same crate multiple times. The reference explains this quite well if you want more details. Okay, we don't want more details. This optimization means that mutually exclusive features may break a dependency tree. In our case, maybe async is sync is a toggle feature enabled by client urec. So if you tried to compile with client request, also enabled, it will fail because maybe async will be configured to generate synchronous functions signatures instead. It's impossible to have a crate that depends on both sync and async RS Spotify, either directly or indirectly, and the whole concept of maybe async is currently wrong according to the cargo reference. Man, this is emotional. The feature resolver v2. A common misconception is that this is fixed by feature resolver v2, which this reference also explains quite well. Okay, what is that? It has been enabled by default since 2021 edition, but you can specify it inside your cargo toml. In previous ones, this new version, among the other things, avoids unifying features in some special cases, but not in ours. Features enabled on platform-specific dependencies for targets not currently being built or ignored. Are ignored. Build dependencies and proc macros do not share features with normal dependencies. Dev dependencies do not activate features unless building a target that needs them, like test examples. Okay. In this case, I tried to reproduce this myself and it did work as I expected. This repository is an example of conflicting features which breaks with any feature resolver. It feels bad. Other fails. There are a few other crates that also had this problem. Arangors, and Aragog. Oh, this is more of those DBs. Arango DB. It's Arango. So it's Arango Rust, Arango RS, or Aragog. Both use maybe async. Damn. Inkwell, a wrapper for LLVM. It supports multiple versions of LLVM which are not compatible with each other. And K8's Open API. Damn. Fixing. Once the crate started to gain popularity, this issue was opened with maybe async, which explains the situation. Okay, here's the problem. Maybe async would now have to have two feature flags, is sync and is async. The crate would generate functions in the same way, but with sync or async suffixes appended to the identifier so that it wouldn't be conflicting. For example, dang, I don't know if this is really winning that much, However, these suffixes introduce noise, and I wonder it would let's see. So I wondered if it'd be possible to do it in a more ergonomic way. Isn't this what the whole async question mark thing is supposed to fix in Rust? Isn't this about to be a language level feature? Sabine, it is. Sabine, I swear this is crazy. But I swear there's like this async question flag Rust right here. I swear there was something I read about this. It's like a potential future that people are talking about. Here. Oh, it's question mark the other way. Yeah, they're gonna be doing these. Hold on. Let's. Oh, question async doesn't exist. Oh, I thought this one would have it. I swear there was one that had. Yeah. Okay. Maybe this goes in more detail about constant async. Yeah, it goes into constant async where you can do these. You can do these like you can go like, hey, this thing could. It could be a problem. Anyways. Man, I love Rust, but its async is so difficult to deal with. It is very difficult to deal with. All right, let's keep on going. We're almost done here, right? We're almost done here. This is very interesting. However, the suffixes would introduce noise. Yep. Let's see. I already read that. In summary, it was about. Let's see. It was too complicated, and I ultimately gave up. The only way to fix the edge cases would be to worsen the usability of rs-podify for everyone. And I'd argue that someone who depends on both async and sync is unlikely. We haven't actually had anyone complaining yet. So it's a fictional problem? Is that what I just read? Let's go. Unlike Request, rs-podify is a high-level library, so it's hard to imagine a scenario where it appears more than once in a dependency tree in the first place. Yeah, this is like the edge of an application, right? Edge of application libraries typically only appear once. Perhaps we could ask Cargo devs for help. Support from Cargo, rs-podify is far from being the first. Yes, there's a whole thing going on. You can look at all those. Blah 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 blah. It's this problem that exists in Cargo. It's crazy. Currently, we have a choice to make between ignoring the Cargo reference. We could assume that no one is going to use both sync and async for rs-podify at the same time. Fixing maybe async to add these suffixes to each endpoint. That sounds terrible. Dropping support for both async and sync code. It's kind of becoming a mess, and we don't have the manpower to deal with and that affects the other parts of rs-podify. The problem is that some crates that depend on rs-podify, like NC Spot or Spotified, are blocking, and others like Spotify TUI are async. Yeah. Damn. This is a real problem you got yourself into. This is tough. This is real tough. I know this is a problem that I've imposed to myself. We could just say, no, we only support async, or no, we only support sync. While there are users interested in being able to use both. I feel like if you only support sync, you could use the Tokyo blocking threads, right? You could let somebody do the async part themselves as opposed to supporting both. It seems like the better choice, honestly, with Rust is just make sync stuff when you can. And just let async be an application level concern. I mean, I know it makes the application more inconvenient to write, but still. Honestly, this sounds really horrible. This sounds terrible. While there are users interested in being able to use both, sometimes you just have to say no. Yes, good job. If a feature becomes so complicated to deal with that your entire code base becomes a mess, and you don't have the engineering power to maintain it, then it's your only choice. If someone cared enough, they could just fork the crate and convert it to synchronous for their own usage. After all, most API wrappers and the like are only support either asynchronous or blocking code. Serenity, Discord API, SquealX, Teleoxide, Telegram are async only, for example, and they're quite popular. I think this is one of the problems of open source in general. You really have to be careful listening to other people. Just to be real here for a second, listening to other people is really difficult because everybody's going to have what they want to see in a library, and what they want to see in a library may not be what you want to build. And sometimes you just build a thing for you and what you want. If you want it to be async, just let it be async, and that's what you want to build. Now, other languages don't have this problem, but Go certainly does, or Rust certainly does. Even though it is quite frustrating at times, I don't really regret spending so much time walking in circles trying to get both async and sync to work. Yeah, this is good. Actually, I'm sure it was very, very educational. I was contributing to RS Spotify in the first place just to learn. I had no deadlines and no stress, and I just wanted to improve a library in Rust in my free time, and I have learned a lot, and hopefully you too, after reading this. It sounds like you approach the problem in the same series of steps I would have approached it. Perhaps the lesson today is that we should remember that Rust is a low-level language after all, and there are some things that aren't possible without a lot of complexity. Anyhow, I'm looking forward to how the Rust team fixes this in the future. So what do you think? What would you do if you were a maintainer of RS Spotify? If I was a maintainer of it, I would build a sync version. I would build a sync version and let you deal with async in the way you want. That way I don't enforce, say, Tokyo, right? Because one problem about writing it in async is often you might have some sort of like Tokyo reference or some nonsense in there that they may not use Tokyo. You know what I mean? I know everybody uses Tokyo. All of this to listen to music. All of this in the end to listen to music. I have a really important question. In your 20 plus years of experience, would be the natural progression of knowledge that you've had over the years. I would like to benchmark, please. You're awesome. Dude, I have no idea what that question even means. So for those that are wondering, because this term colored function keeps coming up and a lot of people don't know what the term colored function means, it's really, really simple. Hey, Crows, thank you very much. Here's what a colored function means. Pretend you had some function, we'll call it red. And for you to call red, you just had to call it this way. Now let's pretend we had another function we're going to call blue. And for you to call blue, you have to call it differently. Let's just say to call blue, you have to call it this way. It's just different, right? Now, what's the problem here? What's the problem here? Well, anytime you had a blue function, you can't have a red function with blue functions. Meaning that if I had my red function, right, inside of it, I can only call other red functions, right? Red2, I can't call a blue function because it doesn't work in my function. So that means to make this work, I actually have to turn it into a blue function, right? And now I can still call my red functions, but my blue functions only work in blue functions. And so then I have to do this whole thing going on right here. So what this really is this, right? And so for you to be able to call a blue function, you have to await the blue function, right? I have to wait for the result to come in. So an await requires you to change how you call your function. And so all asynchronous code, all async await code colors functions. And once you color a function, it becomes really difficult for you to be able to like handle this code. Like, right? Well, once you do that, that's the entirety of the problem we just read. Is in Rust, you have this whole problem of red and blue functions, and then you have to like choose which one you're doing, and you can't mix them. They're very difficult. But in Go, you don't have that function or that problem. In Go, right, you have this beautiful thing where you can go like go, funk yourself and do this thing, right? And blah, 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 blah. And then you just return out, say, a channel, right? And so this function appears to be synchronous despite executing asynchronous. And you just go and do your things, right? You just don't even care. You don't even have to think about it. That's what's neat about Go, is that it doesn't have red and blue. It just has red. Same stuff in JS, no? No, not same stuff in JS. JS has colored functions. You have async and non-async. Changing function colors inside a lib wrapper is kind of terrible too. Yeah, it's extremely difficult. Like, it's extremely difficult, and Rust makes Rust is just peak difficult. This is it. This is truly it. This is what happens with async. Right? This is what happens with async. This is perfect. It says I retweeted it, but I didn't like it. I swear the like always breaks. This is very, very funny. Anyways, the name. Uncommon Ryan Winchester W. Uncommon Ryan Winchester W, but quite the W, might I add. The name is the Primogen.